Hi, Mr. Cursey here. So in this video we're going to concentrate on one question. If we take two complex numbers and multiply them, for instance z1 and z2, is it always the case that the argument of z1, z2 is equal to the argument of z1 plus the argument of z2? And remember, when I say argument, I'm talking about the principal value of that argument. So let's show the product in this case. And yes, that's true. 0.32 plus 1.04 is equal to 1.36. Principal arguments of z1 and z2 add up to the principal argument of z1, z2. So we could write arg z1, z2 equals arg z1 plus arg z2. And that would be perfectly true in this case. But is it always true? Let's move to a different situation, where it now becomes obvious that the argument of z1 plus the argument of z2 does not equal the principal value of the argument of z1, z2. And if we go into more detail about this, when we add arg z1 and arg z2 together, we get 3.51 in this case. That's gone greater than pi. Remember, the principal value range goes from negative pi up to pi. Don't include negative pi, but do include pi. So this sum has gone greater than pi. And therefore, to get it back down, we would have to subtract. Now, how much do we have to subtract? Well, if you look at the diagram, we're still wanting z1, z2, so the subtraction has to be 2 pi. We have to rotate, in effect, z1, z2 by a clockwise rotation, a negative rotation of 2 pi. So what we've done, there's 2 pi, negative 6.28. What we've done is added principal values of the arguments and then subtracted 2 pi to get the principal value of that product. Now that's not the only, let's roll this back, it's not the only situation that might arise. Let's look at, if we like, the mirror image situation, something like that, where we look at these two negative principal values, add them, we certainly don't get 2.35. So when you add them, you get negative 3.93, and you'll notice that has gone below negative pi. Pi, of course, 3.14 approximately. So what do we do to get that back up to this 2.35? Well, we add a positive rotation of 2 pi until we get back to z1, z2. So here we have principal value of z1 plus principal value of z2 plus 2 pi, and we get the principal value of the product. So what have we got so far? We've got the fact that we cannot write arg z1 plus arg z2 equals arg z1, z2. That is not always true, but at the most we would add one lot of 2 pi or subtract one lot of 2 pi. So we can make a statement, and here it is. And our statement has to cover the three situations that we illustrated. So we have arg of z1 plus arg of z2, and we can add 2 pi. There were situations where arg z1 plus arg z2 actually gave us the correct argument, and finally a situation where we add the two of them and we had to subtract 2 pi. So our final statement has to be one statement that encapsulates these three possibilities. So we'll say the principal value of the argument of z1, z2 is equal to the principal value of z1 plus the principal value of z2 plus n lots of 2 pi, where n could be -1, 0 or 1. And that's the final statement, the best we can do. We cannot say it's just the sum of these two arguments for the sum of for the argument of the product. We have to make adjustments sometimes. So now it's your turn. Here's an example. Find polar forms for these complex numbers. If you can stop the video and attempt this, then we'll look at the solutions. Okay, so let's tackle A. We've got the complex number Z1, which is -1 minus I. Let's locate it on an argand diagram. 1 to the left, 1 down. And we'll complete a right-angled triangle. That's length 1. Length 1's half a square. There's pi upon 4 for the angle in the corner there. And then the principal value angle will be 3 pi upon 4, but it's negative. So 3 pi upon 4 in there, and it's a negative value. So we can now establish the polar form. Remember the modulus there, 1 squared plus 1 squared square root of, that would be root 2. Let's put that in. So root 2 times cosine of -3 pi upon 4 plus I sine -3 pi upon 4. Let's now tackle part B. This is Z2, which is 1 minus I. Let's locate that. And again, construct a right-angled triangle. You can see immediately that the principal value of the argument is -pi upon 4. And the modulus is the same as -1 minus I, it's root 2. So polar form, root 2 for the modulus, cosine of -pi upon 4, plus I sine -pi upon 4. So finally we're in a position where we can multiply Z1 and Z2 together. Remember, we multiply the arguments. Root 2 times root 2 is 2. And we add the arguments together. So -3 pi upon 4 plus another -1 pi upon 4, but -4 pi upon 4 for the argument, or an argument of Z1, Z2. And obviously that can be simplified, the 4's cancel, and we have -pi as an argument. Now, is that the principal value? Well, no, because the principal value of a complex number has to lie in the interval -pi up to pi. Now it includes pi, square bracket there, but not -pi. So -pi is not in the range we're after, so we would have to add 2 pi, adjust it by adding 2 pi to that. So let's go ahead and do that. Add 2 pi to -pi, we get pi. and pi certainly is in the principal value for the argument range. And that's us with the polar form of Z1, Z2 using principal value of the argument. So that's Mr. Corsi signing out, and hope you enjoyed the video.